Welcome back to Machine Learning Guide. This episode was AI generated. I do this for fast-moving topics like OpenClaw, Claude Code, vibe coding, where the landscape shifts faster than I can personally keep up. For foundational episodes like backpropagation, logistic regression, those are still me, but for bleeding-edge stuff, I'd rather you have a solid episode now than a perfect one never. And hey, you can generate audio content like this yourself and even use my voice at ocdevel.com/moremlg. Let's dive in. Today, we are going to walk through the guide on agentic software engineering. Before we begin, note that this guide assumes you're already familiar with the core components of Claude Code, such as the claude.md file, skills, commands, hooks, MCP, subagents, agent teams, and headless mode. If you need the fundamentals, you should read the companion guide first. Here, we are going to focus on wiring everything together into real workflows and ultimately into a system that lets you operate as a one-person engineering organization. Let's start with the shift from vibe coding to agentic engineering. On February 2nd, 2025, Andrej Karpathy coined the term vibe coding, which meant giving in to the vibes and forgetting the code exists. It actually became the word of the year for Collins Dictionary. But exactly 1 year later, he walked it back. He said that vibe coding was fine for throwaway weekend projects, but the landscape had changed. Professional developers were now using AI agents as their primary coding interface, not for fun, but for production. His replacement term is agentic engineering. The core insight here is the word agentic, because the new default is that you're not writing the code directly 99% of the time. Rather, you're orchestrating agents who do. The word engineering is used to emphasize that there's an art, a science, and expertise to it. This tracks with what Karpathy calls jagged intelligence, which means large language models solve hard problems easily but trip on simple ones, and it is not always obvious which is which. The job isn't just pressing a button, it is knowing when to trust the agent, when to intervene, and when to run 3 agents in parallel and pick the best output. It is actually closer to managing a junior engineering team than to writing code yourself. But here's the part most guides miss. The endgame isn't just to code faster, it is to automate the entire software engineering lifecycle from ticket to deployment and to elevate your role from the person writing code to the person designing systems, making architectural decisions, and owning outcomes. The software engineer who masters agentic engineering doesn't become obsolete. They become the one person doing the work of a team. This guide gives you the tools, then the workflows, then the full automated pipeline. Let's move on to part 1, the power tools, starting with your MCP stack. Here's the reality. Every MCP server loads its tool definitions at session startup, consuming roughly 4,000 to 10,000 tokens of context. One developer reported having 12 AMCP servers active simultaneously, and they were losing 66,000 tokens before any conversation happened, which is a third of Claude's 200,000 context window gone before writing a single line. The rule here is ruthless minimalism. Load only what you need. Use project-scoped config files so tools load only in relevant workspaces, and lean on Claude Code's MCP tool search feature, which lazy loads definitions and can cut context usage by up to 95%. Here are the servers worth having and why. First is GitHub MCP, which is the single most used server. It gives Claude full GitHub API access, allowing it to create PRS search code, manage issues, trigger actions, and review diffs. This is what makes the workflow of reading the ticket, implementing it, opening the PR, and updating the ticket happen in a single Claude Code session. You add it as an HTTP transport server pointed at the GitHub Copilot MCP endpoint. Next is Context 7. This fetches real-time version-specific library documentation. When Claude hallucinates an API that doesn't exist in your version of React or Prisma, Context 7 kills that problem. You simply append use Context 7 to prompts involving unfamiliar libraries. Then there's sequential thinking. This isn't an external service. It is a metacognitive enhancement that forces structured reasoning for complex architectural decisions. When you are designing a migration strategy or debating between approaches, this prevents Claude from jumping to conclusions. Next is Playwright MCP, which gives Claude browser automation via accessibility snapshots. It can write and run end-to-end tests, scrape pages, debug UI issues, and fill forms, all from the agent. When Claude builds a feature and then tests it in a real browser, the feedback loop tightens dramatically. And then you have Brave Search, which provides real-time web search. This is for when Claude needs to look up an error message, a library change log, or a Stack Overflow solution mid-task. Next is Memory MCP, which offers persistent knowledge graph storage in a local file. This stores architectural decisions, accumulated context, and your preferences so they survive across sessions. This is particularly valuable for solo developers working on long-running projects where context loss between sessions is the bottleneck. Finally, for anyone touching databases, you want Supabase or Postgres MCP. Either of these gives Claude the ability to inspect your schema, write queries, generate migrations, and test them without you needing to copy-paste between tools. For configuration, put universal servers like Brave Search, Sequential Thinking, and Memory at user scope so they are always available. Put Team jagged ones like GitHub and database servers in a project-scoped config file at your repo root, checked into Git. Use the /mcp command to disable servers per session that you don't need. Now let's talk about notable skills and plugins. The skills ecosystem has matured fast. 3 marketplaces index community contributions. Anthropic's official skills repo on GitHub offers production quality, maintains skills for design, document handling, and MCP server building. Skills MP indexes over 200,000 agent skills scraped from GitHub. While the quantity is high, the curation is lower, but the search is good. SkillHub curates about 7,000 skills rated on practicality and quality, so it has a better signal-to-noise ratio. The standout community resource is the awesome Claude code repo on GitHub by Hezrilihim. This is a curated index of skills, hooks, /commands, agent orchestrators, and plugins. It is the best single place to discover what exists. Notable entries include a TDD/command that enforces red-green refactor discipline and manages PR creation, a code analysis command for knowledge graph generation and optimization suggestions, a hook creation wizard that walks you through setup with smart suggestions based on your project, and AutoClaude, which is an autonomous multi-agent framework with a Kanban UI and full software development lifecycle integration. Also, the Skills Universal Installer provides a package manager-like experience for installing skills with a single command. Now let's look at hook patterns that matter. The highest leverage hooks enforce what your claude.md file can only suggest. Here are the patterns power users converge on. First is auto-format every edit. This is a post tool. Use hook that matches on edit and write operations and runs Pretier, or your formatter of choice. On whatever file Claude just touched, every edit comes out formatted, every time without relying on Claude to remember. Second is block writes to protected files. This is a pre-tool use hook that checks whether Claude is about to modify an end file, a lock file, or anything else you have designated as off-limits. If it matches, the hook returns a deny decision and Claude gets told why. Third is block dangerous shell commands. This is another pre-tool use hook, this time matching on bash operations, scanning for patterns like rm-rf sudo, hofmode 777, or drop table. If detected, the command is blocked before it executes. Fourth is inject reminders after context compaction. This is a session start hook with the compact matcher. When Claude's context window fills up and gets compressed, your early instructions lose fidelity. This hook re-injects critical reminders like which package manager to use, what sprint you are in, or what to test before committing after every compaction event. This is one of the most underappreciated hooks. Fifth is desktop notifications when Claude needs input. This is a notification hook that fires an OS-level alert whenever Claude is waiting for permission or has finished a task. This lets you switch to other work without checking the terminal. Finally, the full stack quality chain. This is a post-tool use hook that runs your formatter, then your linter, then a type check, piping the output back to Claude. If anything fails, Claude sees the errors and self-corrects on the next iteration. This is the mechanical enforcement that replaces the phrase, "Please remember to lint in your configuration." You can configure hooks via the interactive/hooks UI or by editing your settings files. Global settings go in your home directory's Claude settings. Project shelled settings go in the .claude directory at the project root. Personal settings that shouldn't be committed go in the local settings file, which is get ignored. Now let's move to part 2, power user workflows. The first concept is the plan first discipline. Every power user converges on the same workflow. The specific prompts vary, but the structure is universal. Start by clearing context. Use /clear to get a fresh context budget, then enter plan mode by pressing Shift-Tab twice. Plan mode makes Claude read-only. It can explore your codebase and reason about approaches, but it can't modify anything. Describe the feature you want. Claude reads the relevant files, thinks through the architecture, and proposes an approach. This is where you push back. Ask what could go wrong. Ask about edge cases. Ask about alternative approaches. The few minutes you spend here consistently saves 30 or more minutes of backtracking later. When the plan looks right, have Claude create a to-do or spec file with milestones, review it. Edit if needed, then switch out of plan mode and tell Claude to implement milestone 1, writing tests first, and then implementation. Committing when done. Watch, approve tool calls, and redirect when needed. When Claude commits, move to the next milestone. When everything is done, have Claude run the full test suite and summarize results. The discipline is plan mode. If you skip it, if you jump straight to asking for a login page, Claude will produce something. It might even be good, but for anything non-trivial, the agent makes better decisions when forced to think before it acts, and you make better decisions when you can see the plan before committing to it. Next, let's discuss worktrees or running agents in parallel. Git worktrees are the most underrated Claude Code feature. They create separate working directories from the same repository, each with its own branch and files, sharing history and remotes. This means you can run 3 to 5 Claude Code instances simultaneously on the same repo without conflicts. As of February 2026, Claude Code has built-in worktree support. Start Claude with the worktree flag and a name, and it creates an isolated worktree automatically. Start another session with a different name, and you have got 2 agents working in parallel. Add the tmux flag to launch Claude in its own terminal session for background operation. Claude handles cleanup intelligently. If there are no changes, the worktree and branch are auto-removed when the session ends. If changes or commits exist, Claude prompts you to keep or remove the worktree. Make sure to add the .claude/worktrees directory to your gitignore custom subagents. Also support worktree isolation. Add isolation:worktree to your subagent's front matter, and it automatically gets its own working directory. This is particularly powerful for large batch changes and code migrations where you want multiple agents working on different parts of the code base simultaneously. The daily rhythm with worktrees is to open 2 or 3 worktrees in the morning for the day's tasks. Kick off each agent with a plan first prompt, cycle between terminals throughout the day, approving and redirecting. Close each one with a PR command, review and merge in the evening. Next is headless mode and external automation. The print flag makes Claude Code scriptable, combined with JSON output format. It returns structured data, including cost, duration, session ID, and result. This is the bridge between interactive development and full automation. You can chain sessions using the resume flag with a captured session ID. Start a session that analyzes a problem, capture its session ID from the output, then continue the conversation with a second command that implements the fix, and a third that opens a PR. Each picks up where the last left off. This is also how Claude Code connects to external automation platforms, but that deserves its own section because it is where the real transformation happens. Now we arrive at part 3, SWE orchestration and the automated pipeline. This is the section that matters most. Everything above the MCP servers, the hooks, the worktrees, the headless mode, they are building blocks. Here we wire them into a system that automates the entire software engineering lifecycle from ticket to deployment. This is what separates a developer who uses AI from a developer who runs an AI-powered engineering operation. The vision is ticket in, deployment out. Imagine this scenario where someone files a GitHub issue describing a bug or requesting a feature. Without you touching anything, an agent picks up the ticket, reads it, explores the codebase, plans an approach, implements the fix, writes tests, runs the test suite, opens a pull request, gets an automated review, fixes any review feedback, monitors CI and auto-merges. When everything passes, all into a staging branch. The only thing left for you is to review the merged result and approve the production deployment. This isn't hypothetical. Every piece of this pipeline exists today, as of February 2026. The question is which tools you use to wire it together. There are several approaches, each with different trade-offs. Approach 1 is Claude's native GitHub integration. This is the simplest path and the one to start with. Anthropic's official GitHub action, called Claude-Code-Action, turns Claude into a first-class participant in your GitHub workflow. You install it by running /install GitHub app inside Claude Code, which walks you through setting up the GitHub app and required secrets. Once installed, you create a workflow file in your repo's GitHub Actions directory. The workflow triggers on issue comments, PR events, or custom events. When someone mentions at Claude in an issue or PR, the action activates. Claude reads the context, analyzes the code, and either answers questions or implements changes directly. But the real power comes when you set it up to trigger automatically. You can configure a workflow that fires whenever an issue is labeled with something like Claude AutoFit. When that label is applied, Claude reads the issue, implements a fix, writes tests, and opens a PR entirely unattended. You can also trigger on new issue creation, on schedule, or on any GitHub event. As of February 20th, 2026, literally 2 days before this guide was written, Claude Code's desktop app added autofix and auto-merge capabilities for pull requests. When you open a PR, Claude monitors its CI status in the background. If CI fails, AutoFix reads the failure output and attempts to resolve it automatically. If auto-merge is enabled, Claude merges the PR via squash once all checks pass. The workflow implication is significant. You open a PR, move on to your next task, and by the time you circle back, the original PR is either ready for final review or already merged. This means the full pipeline looks like this. An issue gets filed. A GitHub action triggers Claude to implement a fix and open a PR against a staging branch. Claude monitors CI on that PR auto-fixing any failures. When all checks pass, Claude auto-merges into staging. You review the staging branch periodically, acting as the human checkpoint. When you are satisfied, you merge staging to main, which triggers your existing deployment pipeline. The beauty of this approach is that it requires almost no infrastructure beyond what you already have. GitHub Actions runs the compute. Claude's API handles the intelligence. Your existing CI/CD pipeline handles deployment. You're just adding a trigger at the beginning and a human gate at the end. Next is approach 2, using N8N or workflow automation to call headless Claude. If you want more control over the orchestration, or if your trigger isn't a GitHub event, workflow automation platforms like N8N give you a visual pipeline builder that can call Claude code in headless mode. The proven pattern, demonstrated by NetworkChuck's N8N Claude Code Guide, uses N8N's SSH node to connect to a server where Claude Code is installed. The flow works like this. A trigger fires, such as a Slack message, a scheduled cron, a webhook from your project management tool, or an email. N8N extracts the relevant information. An SSH node executes a Claude Code headless command on your server, passing the task as a prompt. A code node parses the JSON output. Then N8N takes action based on the result, creating a GitHub issue, sending a Slack notification, updating a database, or chaining into another Claude session. For deeper integration, a dedicated in8n node for Claude Code called in8n nodes Claude Code provides native support for local SSH and Docker execution with persistent session management. Claude Code becomes a first-class N8n node alongside HTTP request, Slack, GitHub, and everything else. You can maintain conversation context across multiple N8n workflow executions using session IDs, so a complex multi-step task can span multiple triggers. Going the other direction, the N8n server gives Claude Code deep knowledge of all 1,236 N8n nodes, so you can ask it to build an N8n workflow that monitors Stripe webhooks and creates linear tickets for failed payments, and Claude generates a deployable workflow. The N8n approach is more powerful than the GitHub action approach because your triggers aren't limited to GitHub events. You could have a Slack command that says fix issue 42 kick off the entire pipeline, or a scheduled nightly job that scans for outdated dependencies, updates them, runs tests, and opens a PR with the changes. Or a webhook from your error monitoring service that triggers Claude to investigate and fix production bugs as they are reported. Next is approach 3, OpenClaw as the orchestration layer. OpenClaw, formerly known as ClaudeBot, takes a fundamentally different approach. Where Claude Code is scoped to your codebase and N8n is scoped to workflows, you define OpenClaw as a life OS that runs on your device and connects to everything, including WhatsApp, Slack, Telegram, your file system, a headless browser, and yes, Claude Code. The relevant capability here is that OpenClaw can act as an always-on orchestrator that triggers Claude Code headless sessions based on events from any channel. You could message your OpenClaw bot on Telegram saying the authentication is broken in production. See Sentry Alert 4521. OpenClaw reads the Sentry Alert, spins up a Claude Code headless session pointed at your repo, has it investigate and fix the issue, then reports back to you on Telegram with a link to the PR it opened. OpenClaw's heartbeat feature. Its cron scheduler means it can run proactive tasks without any trigger at all. This allows for a morning routine that checks your GitHub notifications, summarizes open PRs, identifies stale issues, and auto-assigns any that match patterns you have defined. The trade-off is significant, though. OpenClaw is self-hosted, requires Docker, and has had real security vulnerabilities, including a critical remote code execution exploit. It requires substantially more DevOps knowledge to set up safely than the GitHub action or N8n approaches. Security firms recommend running it in an isolated environment with strict sandboxing. If you're comfortable managing infrastructure, it is the most flexible option. If you're not, start with approach 1 or 2. Finally, approach 4 is direct headless strips on your machine. The simplest version of automation doesn't require any platform at all. You write shell scripts that call Claude Code in headless mode and trigger them however you like, via cron jobs, file system watchers, Git hooks, or manual invocation. A nightly maintenance script, for example, runs Claude Code with a prompt to check for outdated dependencies, update any with security vulnerabilities, run the test suite, and either open a PR with the updates or create an issue if something breaks. You add it to your cron tab and forget about it. An issue to PR script takes a GitHub issue number as an argument, starts a Claude session to read the issue and analyze the codebase, captures the session ID, then continues the session to implement the fix, write tests, and open a PR. You could trigger this manually when you triage issues or wire it to a GitHub webhook. The advantage is zero infrastructure, just your machine and your Claude API key. The disadvantage is that it only runs when your machine is on and connected. Now let's put it all together into the complete pipeline. Regardless of which approach you choose for the trigger and orchestration layer, the end-to-end pipeline follows the same shape. Stage 1 is intake. A ticket is filed, either by a human, by an error monitoring service, by a scheduled audit, or by you triaging and labeling. This is the trigger. Stage 2 is implementation. Claude reads the ticket, explores the code base, plans an approach ideally in a plan-first mode, implements the change, and writes tests. This happens in a headless session or a GitHub action working in its own branch. Stage 3 is self-review. Before opening the PR, Claude runs the code review plugin, which launches 4 parallel review agents that score each issue for confidence. Anything above the threshold, which defaults to 80 out of 100, gets flagged. Claude addresses its own review findings. This is the automated equivalent of a developer reviewing their own work before requesting a peer review. Stage 4 is PR and CI. Claude opens a pull request against your staging or development branch. CI runs. If it fails, Claude's autofix reads the failure output and iterates. This loop continues until CI passes or a maximum retry count is reached. Stage 5 is auto-merge to staging. When all checks pass, auto-merge lands the PR into your staging branch via squash merge. Stage 6 is human review. This is the critical gate. You review what has accumulated in staging, reading the PR as checking the diffs and testing the behavior. This is where your judgment, your understanding of the product, and your architectural vision matter most. The agents did the implementation work. You make the decision about whether it is right. Stage 7 is production deployment. You merge staging to main. Your existing CI/CD pipeline handles the deployment. This part doesn't change. You just added a 5-stage automated pipeline before it. The key insight is that the human never leaves the loop. You're just moved from stage 2, writing the code, to stage 6, reviewing the result. And that is a fundamentally different job, one that scales. Now, what about automated review by others? The pipeline above uses Claude reviewing its own code, which is better than no review but has obvious limitations.
You spend hours learning to optimize model performance, but here's something uncomfortable. Prolonged sitting reduces cerebral blood flow, impairs executive function, and degrades working memory, the exact faculties you need to learn this material. Chronic sitting is associated with reduced hippocampal volume, the region responsible for learning and memory. A walking desk fixes this. A slow treadmill under a standing desk, 2 miles an hour, no sweat, no time carved out of your day. A Stanford study found walking increases creative problem solving by 60%. Separate research shows it raises BDNF. That's the protein directly responsible for neuroplasticity and long-term memory formation. It increases cerebral blood flow by around 15%. And it sustainably improves focus, mood, and energy through endorphin release. I record this podcast on one. I study on one. I code on one. It's the single most important change I've ever made to my focus, energy, mood, and health. I've tested dozens of walking pads and standing desk setups. My top picks and setup guides are at ocdevel.com/move. That's ocdevel.com/MOVE.
The more sophisticated pattern uses a separate subagent with a critical mindset to do the review. The main agent that wrote the code never reviews it, a fresh agent with a different prompt, one that is explicitly told to be skeptical and thorough, evaluates the work. You can also layer this with Anthropic's official code review plugin, which spawns 4 parallel review agents that independently assess the changes. Each finding gets a confidence score. Only issues scoring above your threshold make it into the review. This filters out noise and focuses on genuine problems. For teams, the GitHub action itself becomes the reviewer. When any team member opens a PR, Claude automatically reviews it and leaves comments. The team member addresses the feedback, and Claude can re-review. This creates a continuous review loop that catches issues before human reviewers ever look at the code. Moving to part 4, stepping up the ladder. Let's talk about the career shift from code writer to engineering operator. Here's the career shift that agentic engineering enables, and it is the real reason to invest in all of this. A traditional software engineer spends most of their time in stage 2 of the pipeline, writing code. They read tickets, implement features, fix bugs, write tests, and submit PRE. Their value is measured in output, such as how many features shipped, how many bugs fixed, and how fast. An engineer who has automated stages 2 through 5 spends their time differently. Their day looks like this. They wake up and review what the agents did overnight. They triage new issues, deciding which are worth automating and which need human design work. They review accumulated PRs and staging, exercising judgment about correctness, security, and product fit. They do the creative work like system design, architecture decisions, cross-cutting concerns, and user experience, which agents support but shouldn't own. They maintain and improve the automation itself by tuning the claude.md file, adding hooks, refining prompts, and analyzing failure patterns. This is a different job. It is closer to a tech lead or engineering manager than a traditional individual contributor developer. You are making decisions, not keystrokes. You're designing systems, not implementing them. You are evaluating quality, not producing it. 2 days before this guide was written, a Claude Code creator predicted that the software engineering title would start to go away in 2026, saying the tool now writes nearly 100% of internal code at Anthropic. Whether or not you agree with that timeline, the direction is clear. The engineers who will be most valuable aren't the ones who code fastest, they're the ones who can orchestrate, evaluate, and make judgment calls at scale. This brings us to the data-driven flywheel. The best agentic engineers treat their setup as a system to optimize, not a static configuration. Claude Code stores session logs in the .claude/projects directory on your machine. These logs contain everything, including what Claude tried, what failed, what it had to retry, and what you corrected. The practice is to periodically review these logs or have Claude review them, looking for patterns. If Claude consistently gets the import style wrong, add it to your claude.md. If it keeps trying to use a deprecated API, add a hook that catches it. If a particular type of task always requires multiple correction cycles, create a skill or custom command that front-loads the right context. Research from Arise found that optimizing claude.md through this kind of prompt learning yielded 5% or more general improvement and 11% or more on repo-specific benchmarks. The gains compound because every improvement reduces future correction cycles. Context management is also a meta skill. One practice cuts across everything, and that is aggressive context management. Claude Code's 200,000 token window is finite. Power users treat it like a budget. Clear context liberally. Start a new task with a fresh window. Don't let old conversation pollute new work. Delegate research to subagents. When Claude needs to explore unfamiliar code, use a subagent to do the investigation in a separate context, then summarize back to the main session. Watch the compaction warnings. When context gets compressed, your early instructions lose fidelity. That is why the session start hook with the compact matcher exists to re-inject critical reminders after every compaction. Use worktrees instead of context switching. Don't try to do feature A and bug B in the same session. Each gets its own worktree, its own context window, and its own focus. Keep your claude.md short under 100 lines. Every token loads on every session start and every compaction cycle. The developers finding measurable improvement from optimizing this file are the ones keeping it tight, not the ones writing novels. Finally, part 5, the 3 setups. We will cover 3 progressive setups. Start with the first, come back for the second when it feels natural. The third is for when you are ready to let agents run without you watching. Setup 1 is the disciplined solo developer. You are a developer who uses Claude Code daily, but mostly in a reactive prompt and accept loop. You want to level up to the plan first, quality-enforced workflow. Here is what you will set up. A lean claude.md, a starter MCP stack of 3 servers, formatting and safety hooks, and the plan first workflow discipline. Write your configuration file and keep it under 100 lines. Include your build and test commands, your architecture at a high level with pointers to key directories, code style rules that your linter can't enforce, and your workflow expectations like plan before implementing, write tests first, and commit at checkpoints. Leave out generic advice, long style guides, and inline file contents. Install 3M CP servers at user scope. Context 7 for accurate library docs sequential. thinking for architectural decisions, and brave search for when Claude needs to look something up. That is it to start. You can add more when you have a specific need. Set up 3 hooks in your project settings. A post-tool use hook that auto-formats every file Claude edits. A pre-tool use hook that blocks writes to protected files like env and lock files, and a notification hook that pings you when Claude is waiting for input. Then practice the workflow, pick a real feature, clear context, enter plan mode, describe what you need, push back on the plan, have Claude create a to-do, switch to implementation mode, work through the milestones, run the test suite at the end. The key habit is resisting the urge to skip planning. When you have internalized this, meaning when planning feels natural, hooks handle formatting, and you're comfortable with the approve and redirect rhythm, you are ready for Setup 2. Setup 2 is the parallel operator. You have hit the ceiling of one agent doing one thing at a time. You want to run multiple agents in parallel, automate PR creation, and have Claude handle your GitHub workflow. Here's what you will add: GitHub MCP, worktrees for parallel agents, custom/commands, and the GitHub action for review automation. Add GitHub MCP to your project configuration. Create 3/commands in your project's commands directory, a feature command that kicks off the plan first workflow from a description. A PR command that runs tests, runs the linter, fixes any issues, and opens a PR via GitHub MCP, and a review command that diffs against main and analyzes for correctness, security, missing tests, and style violations. Start running parallel agents with worktrees. When you have a feature to build, a bug to fix, and a refactor to do, open 3 worktrees and give each its own task. Cycle between terminals throughout the day. Close each with your PR command. 3 PRs open in parallel time instead of serial. Set up the GitHub action for automated review. Create a workflow file that triggers on PR creation and issue comments. Now anyone, including you from your phone, can comment at Claude on any PR for analysis or on any issue for implementation guidance. The daily rhythm at this level is to check what Claude's GitHub action reviewed overnight. Tridge issues, open 2 or 3 work trees for the day's work. Cycle through, close with PRS review, and merge in the evening. Setup 3 is the autonomous pipeline. You have got the interactive workflow down cold. Now you want the full pipeline from part 3, agents running without you present, triggered by events, executing headless, and reporting results. Here's what you will add: the automated ticket to PR pipeline, headless scripts for common operations, the auto-review and auto-merge loop, and a human gate before production. Start by setting up the GitHub action to trigger on issue labeling. When an issue gets labeled Claude Autofix, Claude reads it, implements a fix, and opens a PR entirely unattended. This is your first taste of fully autonomous operation. And enable auto-fix and auto-merge in Claude Code's desktop app for your PRs against the staging branch. Now, when Claude opens a PR, it monitors CI in the background, auto-fixes any failures, and auto-merges when everything passes. You have automated stages 2 through 5 of the pipeline. Write headless scripts for recurring tasks. Use a nightly maintenance script that checks for outdated dependencies and security vulnerabilities. Use a weekly audit script that reviews code quality metrics and opens issues for anything that has degraded. Use a triage script you run manually that takes an issue number and produces a PR. If you want triggers beyond GitHub events, set up N8N with an SSH connection to a server running Claude Code. Now, a Slack message, a cron schedule, a webhook from Sentry, or an email can all kick off the pipeline. For maximum flexibility with more security overhead, OpenClaw can act as the always-on orchestrator, responding to messages on any platform and coordinating Claude Code sessions. Establish your human gate. Set a protected staging branch as the target for all automated PRs. Review staging periodically, daily, or after a batch of changes lands. When you are satisfied, merge to main, which triggers your deployment pipeline. The agents handle implementation. You handle judgment. The daily rhythm at this level is to wake up and review what agents did overnight. Check the staging branch, merge what is good. Leave feedback on what needs adjustment. either as comments for the GitHub action to pick up or as refinements to your CLAUDE.md and hooks. Spend your active hours on the work that actually requires you, like system design, architecture decisions, product direction, and improving the automation itself. Let's close with what's next. Claude Code is on a trajectory where the tool itself becomes increasingly invisible. The web version runs in Anthropic-managed cloud sandboxes, allowing you to connect to GitHub repo and code from a browser with no local setup. Sessions sync across desktop, web, and mobile. The Chrome integration lets Claude interact with your browser directly. Remote sessions continue running even if you close your laptop. The more interesting trajectory is what Karpathy flagged. We are early in the decade of agents. Today's power user setup with worktrees, hooks, headless scripts, auto-review, and auto-merge is the manual version of what will increasingly be automated. The developers who understand the principles of agentic engineering, like planning before implementing, enforcing quality mechanically, managing context ruthlessly, and maintaining human oversight on judgment calls, will adapt as the tooling evolves. The ones who memorize specific commands will be starting over every 6 months, but the biggest shift isn't technical. It is about the role. The engineer who automates their own job doesn't lose it. They graduate from it. They stop being the person who writes the code and start being the person who decides what gets built, how it is architected, and whether the result is good enough. That has always been the higher leverage job. The automation just makes it accessible to a solo developer working from their kitchen table. The guide you're hearing is already a snapshot. The setups will change. The discipline will not.
Do you ever wonder how I keep up with the AI landscape? I describe my process at ocdevel.com/moremlg. I use AI deep research to generate episode content, and then I convert that to podcast episodes using AI text-to-speech technology. You can use this workflow for yourself to create additional podcast episodes to listen to, and you can even use my AI voice.
Here's my AI voice in action. Doesn't sound half bad, right? AI through and through, so you can keep on listening to MLG in spirit, but on any topic you're interested in. Go to ocdevel.com/MOREMLG to get more podcast episodes.
You've been listening to Machine Learning Guide, and I'm your host, Tyler Ranelli. MLG teaches the fundamentals of machine learning and artificial intelligence. It covers intuition, models, math, languages, frameworks, and more. It's a start-to-finish audio overview of machine learning principles. Then for topics needing more depth or which are best learned visually, I provide a syllabus of resources at ocdevel.com/MLG. That's ocdevel.com. You'll notice that episode titles start with either MLG or MLA. G for guide teaches theory and fundamentals, where A for applied teaches industry and practical tools. You can listen to either or both depending on your goals. If you want to support the show, like and subscribe in your podcatcher, whether iTunes, Spotify, or YouTube.